My name is Arkadii. I'm software engineer at XCI. Here's my X handle if you want to follow me. It's been a while since I did my last talk, and actually it's going to be the first talk with a live demo in the end. So yeah, first of all, there's a small disclaimer that this talk I'm doing on my own capacity, unrelated to my employer. So all opinions are my own. And now we can start. So the plan of the talk is, first of all, we'll discover why is it hard to debug sometimes, and how MVI, which is model view intent, can help with debugging. And then there's going to be a short introduction to the MVIKotlin library, which I did a few years ago. And lastly, I will show how the time travel debugger works in theory and practice. So why is it hard to debug? So most of you, if not all, know that you receive a bug report and you're trying to reproduce the bug. So if you're lucky and you reproduce it for the first time, or it's like 100% reproducible, it's often easy to find the root cause and fix the bug. But sometimes it's not straightforward. You can either not able to reproduce the bug at all, or it's like flaky. So you can reproduce it maybe 1 out of 10 times, which is annoying. You have to go through steps to reproduce again and again. You add logging, then you realize you need to do something else. You put breakpoint, you put it in the wrong line, and you repeat this process for a long time. So it's time consuming. And there are three primary reasons from my point of view why is it hard to debug. Oh, sorry, why you couldn't reproduce the bug always. So the first one is integration with backend. For some users, backend may return one result. For another set of users, that might be a completely different result. So that's why you are not able to reproduce the bug. The second reason is race conditions. So you made a mistake, or maybe someone else did a mistake. And there's a race condition. So the users might sometimes reach the race condition, and the bug happens. But you are not able to reproduce it because you unlucky probably. And the third reason is state inconsistency, which often happens due to race conditions. So your app sometimes reaches a state which you didn't, as a developer, you didn't expect. And your UI might show, let's say, a success text and at the same time an error text. So here is a very simple dummy example of a race condition. You have a view model, you have a onRefreshClick function, which is called when the user clicks a button. And it shows the loading indicator. And then it loads some data from, let's say, database or network, and displays the data and dismisses the loading indicator. And the user might click this button twice. And if they click it fast enough while the loading is still in progress, the second loading might happen. And once the first loading process finishes, it dismisses the loading indicator, but the second one is still in progress, and it updates the state eventually again, second time. So there is a race condition, and there is also inconsistent state. Your app is doing something when it's on the UI, it's not clear that it does something. So the easy fix in this case is use. Why is it not showing? Yeah. So in this case, it's sorry. Yeah. So in this case, we have to fix this bug. We can use one of the atomic extension functions on state flow. So we can atomically change the state, set the loading indicator, and at the same time, we can check the previous loading indicator. If it was already true, this means that another loading process already happens, and we can do nothing. There's also possible state inconsistency when you have multiple fields in your state. Let's say in this simple example, we have first name in our state, and there is also why it's not showing sometimes? Sorry. Yeah, and there is also can submit flag. So the user may fill in the first name, and then once the can submit flag is true, the user might click the button, and it sends the first name to the server, let's say. But later, you may want to add another field to your state, let's say last name, And you have to keep in mind that canSubmit flag must be consistent. In this case, it's not. And if you fill last name first, then first name after that, it works fine. But if you fill first name first, then last name, you're going to have problems because canSubmit will be enabled straight away, and the user might push the button before filling the last name. We don't want that, so you have to keep in mind and also update the canSubmit flag, taking into account first and last name. So what is MVI and how it can help with reducing race conditions and state inconsistency? So first of all, there is no official answer what is MVI. There is no wiki page, let's say, unlike, let's say, MVVM or MVP. But there are some decent and very good articles on the wild. And one of them is actually a series of articles written a long time ago by Hannes Dorfman. They're still relevant, but they're old. They still use Java. But as a reference, it's very good. The link will be provided in the end, don't worry. MVI is inspired by Redux, which is a JavaScript library for predictable and maintainable global state management. And what distinguishes MVI from, let's say, MVVM is there is usually a single function, a pure function that takes the current state, an intent or an action you want to apply to the current state, and it returns a new state. It does not do any side effects. It's easy to test, and it must be present if you are doing MVI. And the point I would like to add is state is not necessarily global, unlike mandated in Redux. You can, in Android, let's say the Kotlin multi-platform, you can define your state locally to a feature or screen, or it might be a part of screen, not necessarily global to the entire app. So we have this reducer, pure reducer function. And if you're using declarative UI like Jetpack Compose, you probably have your UI is a function of a state. So this both together give you predictable and consistent user experience, usually. So this is a simple example of a reduce function. So you have the current state, you pass the intent, which is a sealed interface like increment and decrement, and it copies the state, returns a new copy with a new data. It's very easy to test. So reducer is a pure function that takes the current state and intent as inputs and returns a new state. But in real app, there are also side effects. What about side effects? There is no standard approach at MVI. Every library does its own, handles side effects on its own. But as a general rule, side effects happen outside of reducer. Reducer is a pure function. You can do whatever you want outside. So what about MVIKotlin? So first of all, MVIKotlin is a library that I implemented maybe 6, 7 years ago. It's still relevant. I still keep up to date, updating Kotlin versions, etc. And the two main entities of the library is executor and reducer. So we all know what reducer is, but executor is a dirty place where you can run side effects. You can call network, you can call database, and once you're happy, also you can read the current state, and once you're happy, you can send messages to reducer, and it returns a new state. So you send intent, your executor does something, might call side effects, and once the processing of the intent is done, it sends a message to the reducer, and it takes the current state, and it applies the new state. And this executor and reducer altogether called a store. Why store? Because it stores a state for you. And if you have multiple stores, let's say on the same screen, you maybe have 2 stores, or you have a stack of screens, each with its own store, so they can communicate between each other. So one state can emit a label, a special, let's say, sealed class, and you can map this label to an intent and pass to another store. And the good part is you don't need to implement the store. You only need to implement the components like executor or reducer, and you can use the store factory provided by the libraries, predefined implementations. So you pass your components in there, and it returns you an implementation of store. What implementation? Depends on the actual store factory. So let's say this is an example of, let's say, item details store. You have maybe a list or a screen with details, some details by item ID. and you make it an extension of store factory. So you call the create method, you pass the executor implementation as a class below, and you also implement the reducer function, and it returns you a store implementation. You can send intents into and observe the state and render your UI. And in simple cases, there is also a DSL, like you can call coroutine executor factory, or if you use like Rx, there's also Rx executor factory, and you can use on intent DSL function for simplicity. Right. So store factory, it wires store components together. It manages communication between stores, between store components. It also provides additional features like time travel, logging, and etc. And store factories can wrap each other. So let's say you can use a logging store factory to add logging, and you can pass in the default store factory, which is production implementation. So everything works together, and you have logging. Or you can use time travel store factory, which is like default store factory, but it's able to record all state changes, all events, and you can travel back in time. We'll discover it later. So time travel. Let's say you have your store. It currently has state 1, and there is time now is t1. So you send an intent add item to the executor. The time travel store records this intent as well as the current state 1 at time 2. Now, once your executor sends a message to the reducer, the store records this as well. So you have the third line, add item, and the current state 1 at time 3. And the reducer returns the state 2. It's also added to the list at time 4. And now the time travel store implementation, if you ask it can switch the state, replace the state with the old one, which is state 1. And it disconnects your store from the inputs and executor from everything else. So it's like the state cannot be changed. So UI renders state 1, which you ask it to do. And the best part is you can trigger individual events that happens in the past. So let's say you want to debug this add item event at state 1. So you click the bug button, and the implementation creates a new instance of the executor for you, replaces the state with state 1, and you can put your breakpoint in there and debug as many times as you want. You don't need to go through all the steps to reproduce. You already have everything. And the same for the reducer. You can click the bug button on the add item message and put breakpoint on your reducer and see what state was, what data was in the message, and why you got the, let's say, inconsistent state 2. And I think now it's time for, there should be a nice image. Yeah, now it's time for a live demo. Let's see how it works. So we have this list store factor. This is actually a sample in the main repository. I will also provide a link later. Like database main context, IO context. Let's run it on Android, the app. And there's also a nice application which you can download for all operating system from the repository, from releases page. So you can use it as a client to control your time travel. There is also a plugin for IDE if you prefer plugins. So yeah, now it runs. Right. So there is like simple to-do application. You can add something here, and like it appears in the list. The image quality is not so good. Yeah, I know. Sorry about that. So let's try to connect our debugger. So you push this, first of all, settings. It can connect via ADB for Android or via your normal TCP/IP connection if you're using any other platforms. So what it does, you run a time travel server on your application, which accepts connections from outside, and this client application connects to your application. You can even do remote debugging, you know. So let's say via ADB we can connect to our application. Now we want to record events. So here I press 1, 2, 3, and now we can stop recording, and now we have everything here. So let's say there was an intent set text 1, then there was a message to reducer, the text changed to 1, and there was a new state with text 1, and same for 1, 2, 1, 2, 1, 2, and 1, 3, 1, 2, 3. It's actually composed multi-platform. And the coolest part is you can like roll back state. You can see it rollbacks. Right. And now you can debug, let's say you want to debug your reducer at message text change it, initial one. So you put a breakpoint here. You attach your debugger. And now in that application, you push this debug button. What happens? Why it's not working? Sorry, let's try again. Something is wrong. Ah, I don't know. Let's try maybe iOS. Maybe iOS will work. Let's try. Yeah. Okay. I think I know what's the reason. Let's try again. Yeah. Okay, this is a different store. Sorry, yeah, I was wrong. So if yeah, okay, now I got it, sorry. So if I click add item, oh, yeah, sorry, like this, okay, from the beginning, yeah. So if I click add item here, like this, so there's now list store with add to state. So yeah, it's added a new item to state. And now we can debug this, let's say added item event. So we can put breakpoint. Sorry about that. The debugger was not attached. First live demo. Now it should be. Yeah. Okay. Now do it again. Connect. Why? Why is it so flaky? Okay. Yeah. But at least we now know the reason why it didn't work. Yeah. Give me a sec, please. Okay. Yeah. Okay. Now we can add an item, let's say 5, to the list. And now we have this thing. So we stop recording. We put breakpoint here. And we attach debugger. And now if I click here, this debug button, now finally it fires. And what we have here, we have this message, add item, with like identifier and data. We put text 5 here. And we can also see this the current state with 2 items. And you can like do this again and again. And the same for executor. Let's say I want to run it. And now I want to debug the intent. So I put breakpoint here. And now I can click debug this add to state intent. So here's the intent with the item, with the text, just text. And you can also check the current state by calling this function state, which is on the current state of the executor. And you have 2 items in the state. And probably the other part I wanted to show is you also can debug your browser. So there's a web app. You can run it in the browser, the same one. And you can also have the plugin. You can download it from Chrome Store. Wow. Wow. Okay, like this maybe. Yeah, you can connect, you can click record, you can add an item there, and the same, you can see everything. And you can even debug, but debugger for web apps is not so good. I tried it, you can't even, it misses the lines, something wrong with mapping. So yeah, but anyway, it works. Yeah, I think that's it. And let's back to the presentation. There's supposed to be a nice video. Yeah. Generated with Grok Imagen. Try it. Yeah, finally some links. Feel free to take a picture. And if you have questions, I'm happy to answer.
Thank you very much, Arkadii. Don't worry about mistakes or not functioning live demos, because for audience, it's sometimes better when things are not working according to your plan, because then they can actually see you thinking about how to actually solve the situation. So it's absolutely okay. It was perfect. And we have two questions here. So first one related to MVIKotlin. Can I create my own store factory using Kotlin MVI? I would say yes.
Absolutely, it's an interface. You can implement it very easy, and you can use the existing implementations as an example.
So absolutely. Yeah. And then there is another one from Daco. How does MVIKotlin compare to Mozilla RR? RR is record and replay of all memory. MVIKotlin seems on the framework level, not a language level. Have you considered trying to do this at the JVM level?
Well, honestly, I don't know what is Mozilla RR.
Is the guy who asked this question here? So maybe you can come here, because we have quite some time, so we can discuss it in detail.
So Mozilla RR is like a GDB extension.